goodness. There we go.
Yeah, the one with electricity.
No, this... Oh yeah, this was the end of semester 1 exam I was doing it for the January students. So this was one of the questions on it. Okay, let me delete that.
How did they do?
Yeah.
How did Fawn do?
Remember, it was a B or an A. She did good. She did good.
How did Yahya do? If I may ask.
I honestly don't remember. It was okay. I think only one person failed. They're the people I worry about. They keep me awake at night. Okay, so what is the values here? What's the first the row that they have? Frequency.
Yes.
Frequency in hertz, yeah?
Yeah.
Okay, so I'll draw that in frequency in hertz. And the values are?
250.
And increasing or decreasing?
450.
Up to 450.
Yeah.
Okay, then.
No, like 50.
Oh, in 50s up until
Yes.
450.
Yes.
Okie doke. That's all? Okay.
Yes.
And what's under that?
Length.
In meters.
Yes.
And
0.339.
0.339.
0.283.
0.283.
242.
242.
212.
212.
180.
And then the next one is time,
Yeah, 1 over.
which is the seconds, which is 1 over frequency, isn't it? Yes. Okay, so that's all fine and dandy, isn't it? And what did they ask you to draw?
Time on the y-axis against length.
So I'll plot these two basically on x and y. Alright, this is all fine and dandy. So let's plot these two, see what we get.
The one on the right is supposed to be on the...
That's what they said in the question, you said.
Yes.
Yeah, so I want to insert, where's my chart gone? Chart. I want a scatter plot. I know, it's loading. It needs to give me my choices. Scatter plot. And let me see, next. So, the title is, what's on the y-axis? Time against length. And the x-axis is length in meters and the y-axis is time in seconds. Yes, it's increasing. Oh, I said I didn't want this.
When are we going to get the results for the essay?
I have your results. I thought I said if you need them you can come to the office. If you want I can put them on the notice board. The problem is every time I come to this class I never think about bringing the results. But I have the results, they're in the office, you can come and get them. Or if you're happy for me to put them with your student number on the notice board, you can do it that way. Because I know we're both busy, so I don't know at what situation we're both free at the same time, you know. If you want to come by, that's fine. If you want me to put them on the notice board, would all of you be happy with that?
Which
Everything, maths, physics, everything on one page. This is what you have. This is how you are. Yeah, I think it would be a useful thing. I can even put on it what grades you need to get to achieve certain grades in the final exam. This is what I usually do. So like to get a B you need whatever. Okay, so that's my graph. Happy with that? Yeah. What's the next question then?
Draw a diagram showing the amplitude, particle displacement at the first position on radar.
This is what Musharif you were asking about, was it?
Yeah.
Is it open or closed? What's it say about the pipe?
About close
Closed at one end. Yeah. Like this. And this is a node. And then here is an anti-node. and then this is the length of the pipe, and the wavelength is 4 times the length because there's a quarter of the wave in here. Was that the question in total?
No.
Draw a diagram.
Draw and label, like please draw and
Closed and open and pipe wave. I can't
do I need to draw this?
draw what?
Right.
Yeah.
Then what? Read exactly what it says.
Draw the I'm showing that the just particle displacement at the credit position of this one.
Oh, I misunderstood you. Maybe this is the next question. Is this draw the node antinodes?
And label the node and antinode position.
That's all they said, yeah.
In the same question?
Yeah.
Okay. So, yeah, no, this is it. And this is the amplitude here. And then here there is no amplitude because there's no displacement. Yeah. This, how many marks is this? This is all 3 marks for sure. Yeah. You look. I would, personally I would, although the marking scheme may or may not, but I definitely would want it. It makes me happy. That's pipe drawn. What's the next part then?
So that then correction of the air current will ignore it whenever it equals 4 lambda over v, where v is the velocity.
Oh wait, well this is okay, so you have V equals lambda f, and what formula do they want? A formula for
1 here.
1 over f is what they want, is it? So then 1 over f, if I rearrange this, it would equal lambda over v, and lambda is 4L, is this it?
Yeah.
How many marks? 1?
2.
2. Okay. Can I what?
Slow.
No.
Lambda equals 4L. Because it's first position. Because
I rearranged this to get 1 over f equals lambda over 3. Happy or unhappy?
Yeah.
And then lambda is 4L. From here, earlier. I said this earlier. What's next? B or still A?
So they use the gradient of the graph to determine velocity.
Right. So the graph was a plot of, what was here?
Time.
Time, and this was
Then.
length. Okay. So the slope here is equal to time over length. Yes? Those sneaky guys. But what's time equal to? Time is 1 over f over L. But what's 1 over f? This. Because that's what they just asked you to show.
Yeah.
So I can change this into 4L over V over L. What cancels here? The L's. So then you end up with saying slope of the graph is equal to 4 over V. So V equals 4 over slope. So if I get the slope here and do 4 divided by the slope, then I have the speed of sound, which should be about 330. Now, how do you get the slope here? You need to draw a triangle. But, come on, I want to cheat.
If I get the slope of the line, is it,
1 over x.
like y2
What?
minus y1?
Yeah. I'm being lazy and getting the program to calculate it. Show equation. So I can see the slope is 0.01177. So if I do 4 over 0.01177, what do you get, Sharif? 354.9. Okay. Not too bad. Bigger than you would expect, but not too bad.
How much is
Oh, she's about 340. Okay. What's next then?
Help the diagram describe and distinguish between progressive longitudinal and transverse.
Is this B?
Yes.
Right, who remembers which is which? We'll start with, whatever, what's the first one they said? Progressive, longitudinal? So what's that one? Do you remember?
The one that's parallel,
Yeah. So,
the vibration goes with the
yeah,
oscillation.
that's it. So here's the oscillation, and here is the direction, the propagation. You need the words here. So in the progressive is a synonym of longitudinal waves. You can call them progressive waves, or for short, P waves. P waves are waves in which the oscillation happens parallel to the direction of propagation. So this is the direction of propagation. It's the way the wave is moving. And here this is the oscillations, the vibrations. So it's moving in the direction of the wave. And then the second one is the, what do they call it? Transverse or S waves, yeah, which S stands for, did they say what the S?
You said you didn't remember.
And I still don't remember.
It's transverse.
Yeah, which they call an S wave, but I can't remember what the S stands for. Oh.
Maybe I shouldn't have told you that
Yeah, I could have. Doesn't matter. Transverse waves or S waves. Transverse waves, blah, 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 blah. Perpendicular. Blah, 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 blah. Huh?
I did the presentation.
Okay. What's next now? Is this B part 1?
We should draw a diagram. So
Oh yeah, so it's this one. Propagation, oscillation.
C.
Oh, C.
No,
All right. Is there 2 C's or 1 C in oscillation?
2C.
Is it 2 C's?
2 and 1.
2 S's and 2 C's, or 1 S and 2 C's?
Sorry?
Oscillation. 2 S's and
sorry. I thought
2
you were
C's?
it's OSC.
Huh?
OSC.
1 S.
Yes.
2 C's?
1 C.
Oh,
I thought you were talking about the question.
no.
in the second one, which one is that?
Hell colored. Replace the word parallel with perpendicular. Yeah. I should be a bit more academic with my English. What's a better verb than happens? Occurs, yeah. I should really say occurs, yeah. But you're not getting marks here for your grammar, it's just for the idea. P waves are waves in which the oscillation occurs parallel to the direction of propagation. Yeah? Okay. What's next now?
C. A stress strain.
Yeah.
2.25 meters long is made to vibrate at its fundamental frequency.
2.25 meters long, and it's stretched between
3.25.
3.25, okay?
It's made to vibrate at fundamental frequency.
Yeah.
The stationary wave pattern is forming.
Okay, so it'll look like this then. Yeah.
The fundamental frequency is 30.5.
30.5 hertz, okie dokie.
Catch the appearance of stress.
Okay, I've just done that by accident. Right. Here is.
So it's third harmonic.
Oh, well then. Third harmonic. Ah, rats. That's the first one.
You have to throw another one at the same, but the second one.
Yeah.
And the third one you have to draw
Psi. Right, let me do the second harmonic. So it goes up,
down.
like this. Is it?
Yeah.
Okay. And then the third harmonic?
Up, down.
Up, down, boom. Alright, this is the third harmonic. Super.
Determine the difference between antinodes and
Ah, well, okay. That's it. Well, there's an antinode. There's an antinode. There's an antinode. So this is a quarter of the wave. This is half a wave, quarter of a wave. What do they want the distance between the antinodes?
Yeah. Determine the difference between antinodes at this frequency.
Oh, distance between antinodes. Okay, yeah. So this antinode and this antinode are half a wavelength apart, and this one is also half a wavelength apart. So the distance is half a wavelength. How much of a wave do I have here? Do I have 1.5 full waves, is it?
Yeah.
1.5 waves. So the wavelength, 1.5 times the wavelength is equal to 3.25. I have 1.5 wavelengths here, and that's equal to 3.25. Is that okay, or is that confusing?
That's confusing.
Yeah. How much of a wave do I have here? 1.5. So 1.5 is 3.25.
Okay.
So that means the wavelength is 3.25 over 1.5, half of that.
You didn't divide it by.
And then divide the answer by 2 then.
1.08.
Seems reasonable.
But why divided by
Yes.
Yes, because the distance between the antinodes is half a wavelength.
Oh, okay.
So I take the wavelength and divide it by 2. And this is the wavelength here from the previous line.
This is the X signal.
The X? Oh, okay. I call it the X if you prefer. Yeah? You look so confused. Good. Is there another part?
No.
B5.
The next question.
And we finished.
Hmm?
Yeah.
And we finished.
Final question.
That's
Absolutely.
done now.
Okay, good. Right, let's see, what is B5 now? What is B5? Is it good, bad?
First orbit, the sun, around fast radius 1
Nice. Fields. We haven't done any fields exam question yet. Go for it. A part 1. I think these are difficult enough to do them one by one. So just do part 1, okay?
Angular speed is omega.
Yes.
Radius is omega. No, it's omega. This is omega. Omega is equal to this. You have the omega in one bar. You want time. Okay, wait. V equals omega r 2 pi over t 2 pi over omega is the time. That's it.
That's it, yeah. That's it.
So by it's not
Numbers. days.
They said they wanted in days.
Yes.
Divide by.
So what did you get here when you divided? Firstly, probably got loads of seconds.
Yeah.
What? Read them all out. One. Give me the first. Digit by digit. What have you got?
3155.
3155
7937.
7937.
Point
0.25 divided by this. If we divide by 3,600, that's hours, and then divide by 24, that makes it days.
That's a year.
Yeah, what you got? 300.
No.
65,
Oh.
yeah.
Wait, do they want it in days? Yeah. So what did you get?
55.25. Exactly.
No. There and for.
This is a year actually. A year is
4 years is 360.
Yeah.
yep, correct. Right, so that's fine, isn't it? What's part 2 now?
Determine the frequency, 1 over that.
Oh, well, that's all easy peasy still. Yeah, what do you get for that then?
1 over
No, it's 1 over this previous one. Although you could use this, but your answer would be in per days instead of in hertz, but that's
Can I
fine.
use hertz?
Yeah, but you have to go back to using this for the time.
No, can I use the 365 days and say hertz? Is that wrong?
Use in which part, 1 or 2?
1 over 365.25.
Yeah, but you can't say hertz.
I can't.
Cannot. Because hertz is when the time is in seconds. Yeah.
What was the unit?
I will,
Per day.
just per day.
What's the point? Okay, 2.737 per day. Times 10
it would be, yeah, actually it'd be 1 over 31557937.25. Because that's the time you got previously. So what's that then? It'll be small.
3.17.
Yep. Yep. Yeah. Okay. Part 3 now.
Mass of the sun.
Yeah, okay, I'll let you think about this one now. This time now you will have to use some kind of circular motion formula. And Newton's law of gravity.
Yeah.
You may need one or both of these. I suspect you will need both. Or, if you remember Kepler's second law, you could use Kepler's second law, but this law is not in the formula book.
Yeah.
Is it not?
It is not.
Faith.
Because, why is it not in the formula book?
Why not?
Yes, it's one of the 3 proofs in the exam.
Oh, okay.
What?
Should be both.
Maybe that's example.
No.
Can you say that? No. Why?
I can't say it in the exam.
Yeah,
But I'm going to do it in a minute. But now, you see, this is real life. If you don't remember Kepler's second law, then you have to do it some other way. So see what you can do.
E equals and then
It's what equals?
E.
No.
E squared.
Yes.
E squared equals. Where is the Q? M.
It's a good question.
M down. In there. Yeah.
Is it, or is it top?
No.
I don't know.
not top.
Are you sure?
Yeah. Double E.
But maybe the M is with you.
No.
TM over R.
Yeah, isn't it? Isn't it? And there's a pi squared in there somewhere, isn't there?
No.
Oh my God, wait.
Over small
We should search for it.
Yes, now you're thinking. Just Google Kepler's second law formula. There might be an R cubed in there as well somewhere.
Yeah, in the thing.
In the denominator,
In the
yeah.
denominator.
Take something else.
Not that we can do it.
Okay, look, Mushari.
Gm over R squared.
No, that's for G formula. Here, look, I'll prove it. We can do it really quick, okay? So you have, look, T is 2 pi over omega, right? But omega, well, we'll leave it like that. Let's write down the formulas. You have F equals G M over R squared. And from the circle you have F equals M omega squared R, where big M is like the sun and small m is like the earth or something. Because they're both equal to each other, we can say this. So obviously these small m's are gone. Yeah. And when the R, we can say Gm over R cubed equals omega squared. But omega is 2 pi over T squared. So you get T squared equals 4 pi squared or 4 pi squared or cubed over Gm. And this is Kepler's second law. Huh? We need the m, so we should rewrite this as m equals 4 pi squared or cubed over gt squared. So if I go back to the question now, that would be 4 pi squared times 1.49 times 10 to the 11 cubed over 6.67 times 3155793.25 squared. Did I make a mistake here? Ten to the 19?
Yeah.
Okay, I thought it was going to be bigger, but I do remember the 1.97. Oh, sorry, I forgot something in my formula. Keep that answer. I forgot G is 6.67 times 10 to the minus 11. So if we add 11 to 19, we get 30. So it's 1.97 times 10 to the 30 kg.
Yes.
Yeah. That, in fact, if you Google, have a quick Google there, mass of the sun, and I believe your answer will be 1.99 times 10 to the 30.
How much is it? Yeah.
1% error. Not so bad.
For the sun, yeah.
For the sun, indeed.
Might be the half of
Have we finished the A parts?
Yeah.
Yeah, we have.
Yeah.
So, next time we'll continue with the B and the C part then. Okay?